In this video, we want to talk about multiplying fractions. The algorithm for multiplying fractions is much simpler than adding fractions, but it's equally difficult to visualize. So I want to make sure that while we are talking about multiplying fractions, we're seeing what's going on. So let's start with a very basic problem where you probably know the answer right away. Let's take 1/3 times 6. Now, as a word problem, this may appear as what is 1/3 of 6. So the key word being of. When you see a fraction followed by of, you should right away think about multiplying. You probably realize that we would get the same answer if we had simply taken 6 divided by 3. So let's work this out arithmetically first, and then we'll make visual sense of this. So one of the things you should always do when you're working with fractions and integers in the same problem is convert the integer into a fraction, because it is. It's 6/1 is the same as 6. And if we look at that, we can now take advantage of some of the properties that we talked about previously. We have a lot of things going on. We have 1 being divided by 3, and then that's getting multiplied by 6. But we can think of this, we can use the commutative and associative properties to move things around and regroup them. It does not matter if you multiply by, take 1 and divide by 3 and then multiply by 6, or switch the order around. Take 6 times 1 and divide by 3 times 1. So have switched the order of the numbers in the numerator and denominator using the commutative property. Now we can turn around and we can associate 1/1 and 6/3. And so suddenly it makes sense why the answer to this problem is exactly what we would have gotten if we took 6 divided by 3 in the first place. So we end up with an answer of 2. Now, what does this visually, how does this work out? So what is 1/3 of 6? Well, let's consider unit blocks. So let's literally take 6 blocks. There are 6 of them. We need to cut this into 3 parts. That's what it means to take 1/3 of it. So if I slice it twice, 2 cuts will always give me 3 parts. 4 cuts will give me 3 parts, and so on. So 3 cuts gives me 2 parts, and 1/3 of 6, we can take one of the parts, is right down here, and it looks like we have 2 blocks filled in. Now that may seem a little bit trivial, but let's expand this and look at 2/3 times 6. So let me clear the ink. Okay, so once again, arithmetically, this is quite easy. Let's take 2 divided by 3 times 6/1. Now we're allowed to do things in a lot of orders. Okay, so let's consider a couple possibilities. We could take 2 times 6 and then group those together, associate those, and divide by 3. And that would be 12 divided by 3. Which we know is 4. We could also take 2 times 6, and we could commute the 1 and the 3, and we could associate the 6 and the 3, and the 2 and the 1, and we could say that 2 divided by, put a little dividing line here since we're doing 2 different things. So we could say 2 divided by 1 is 2, and 6 divided by 3 is 2, and then 2 times 2 is 4. So we get the same answer. We can commute things and associate things in different ways and still get the same answer. So the mechanics are relatively easy. But let's try to figure out what it means visually. So 2/3 of 6. Well, let's once again draw 6 blocks. 1, 2, 3, 4, 5, 6. Now, what does it mean to have 2/3? Well, we need to multiply by 2. So we have 2 sets of 6, and we need to divide those up into thirds. So you'll see that we have 1/3 of the blocks here, 1/3 of the blocks here, and 1/3 of the blocks here, but we're twice as wide because we have 2/3 instead of 1/3. And if we look at one region, inside of that region, we will have 4 units shaded in. So that's the visual meaning of 2/3 times 6. Let's look at another problem. What is 2/3 of 5/2? Okay, so let's look at this one visually first. So what would 5/2 be? Well, we know as a mixed number, I hope you know that 5/2, if we do the division, is equal to 2 with 1/2 left over. So 5 divided by 2 is 2, but there's 1 as a remainder, so we have 1/2 left over. So let's draw out 2.5 blocks. 2.5. Now we're supposed to take 2/3 of 5/2, so we have to have twice as many as 1/3 of 5/2. So let's draw a second set of 2.5 blocks. And now we need to divide in thirds. Let me pick a different color here. Where would the thirds line be? This will be a little trickier to eyeball. Probably a little higher on this one. So let me draw a line there and a line there. And it looks like I divided those pretty evenly. So we are down to having this region here. Okay, and how big is that region? Well, you can see we have almost 1 block, a little less than 1 block, and a little less than 1 block. So when we add those up, we'll get something that is less than 2. All right, it's hard to say exactly how big it will be, but it's going to be a little less than 2 full blocks by the time we finish the problem. So let's work on this arithmetically. So 2/5 times, 2/3 times 5/2. I'm rewriting the problem. I've replaced the traditional x as a multiplier with something you'll see more often as you move along, the dot. And now let's apply what we've been talking about. So we can commute things. So let's commute the numerator. Let's have the 5 times the 2 instead of the 2 times the 5. And let's have a 3 times a 2. Now we can associate things. 2 over 2 is clearly 1. So what are we left with? This simplifies down to 5/3. Okay, now let's write that as a mixed number. That would end up being 1 and 2/3. Now we had said that the answer should be a little less than 2. Well, 1 and 2/3 is exactly 1/3 less than 2. So that corresponds pretty nicely with our visual image. Let's try one more. That last one worked out nicely because the 2's divided out very well. So let's take 3/2 times 5/2. Now this is a little bit trickier because we're multiplying by a fraction that's bigger than 1. So once again, let's draw this out. So 5/2, that's the same as 2.5. There's one of them, but we're going to need 3 of them. So let me draw my boxes on over here. So we now have 3 5/2, and we want half of those. So let me draw, that looks to be about the halfway line. And let's try to figure out how many we have. We clearly have, if I draw a second little line here, this is clearly, let me just write in, that's clearly 1 full block. That's clearly 1 full block. This is clearly 1 full block. And when we add the other 3 together, it looks like all 3 of those are a little bigger than 1. Okay, so if we look at this, since 3 of them are a little bit bigger than 1, and we already had 3, it looks like our final answer is a little bigger than 4. Let's work it out arithmetically. So 3 halves times 5 halves. Associating things in different ways doesn't simplify the problem. We can't associate anything in the numerator with anything in the denominator, but we could associate the numerator, the 2 values in the numerator with each other, and the 2 values in the denominator with each other. You don't have to write those pink parentheses in. I'm just showing what my thoughts are. And so when we write this out, we have 15 in the numerator, and the 2 times 2 in the denominator gives me 4. Now, to see if our picture is right, let's convert this into a mixed number. 4 goes into 15 evenly 3 times, and there are 3/4 left over. So it looks like I was actually wrong about this when I drew. I thought that it would be a little bigger than 4, but clearly my drawing wasn't quite to scale. So my answer is really a little less than 4. But this is the correct answer. So my picture was just off a little bit on its scale, but you can see roughly the visual meaning of all of this.